Hello everyone, my name is Kamble and I am going to present my ISE activity of solid mechanics, which is cantilever beams in aircraft or antenna mounts. And first is introduction to cantilever beams. So let me introduce you to a cantilever beam, which is fixed at one end and free at other. This simple structure is used everywhere in aerospace, from wing spars to landing gear supports in aircraft antenna mount. A cantilever beam design allows the antenna to extend outward from the aircraft body without requiring additional supports. This helps in achieving clear and effective signal reception. So cantilever beams are very important in aircraft structurally speaking, and also speaking in the sense of like antenna mounts. First, there are various forces acting on these cantilever beams. There are three types of forces acting on cantilever beam. During flight, the antenna experiences aerodynamic forces like drag, which tries to pull it backward. There's also static weight of antenna itself, which constantly loads the beam. And finally, dynamic loads, that is vibrations from engine, turbulence and sudden maneuvers. All these forces can cause mount to move or bend slightly. That's why minimizing this motion is critical to maintain proper signal alignment and overall communication reliability. Then let's talk about beam deflection theory. To understand the concept of beam deflection, deflection refers to how much beam bends when load is applied. In the case of antenna mounts, even a small amount of bending can shift antenna direction. Deflection increases with beam length, decreases with stiffer material, and depends heavily on beam's cross-sectional shape. The type of load, whenever point load or distributed load, also affect beams. This is why engineers carefully calculate deflection during the design stage to ensure the antenna remains stable and accurate. Then, to prevent this deflection, we can use different types of material. Aluminum alloys are commonly used because they offer great balance between weight and strength. Composite materials are even better in some cases. They are lightweight and extremely stiff. Titanium alloys are used where high strength or temperature resistance is needed. Engineers also optimize the geometry of the beam, for example by using hollow tubes or tapered design to increase the stiffness without adding unnecessary weight to the aircraft necessarily. Then let's talk about mitigation of this deflection. So what happens if deflection becomes excessive? First, the antenna may lose alignment, resulting in weak or lost signal. Second, repeated beam bending can introduce fatigue, stress, which may eventually lead to cracks in mount. And third, vibrations or resonance can damage the antenna equipment itself. To prevent these problems, we use high stiffness materials, optimized geometries, and shorter beams, and sometimes additional supports or brackets. All these strategies help keep the antenna stable even under harsh conditions. And conclusion. To conclude, controlling deflection in aircraft antenna mounts is essential for accuracy, reliability, and safety. By selecting the right materials, design, and correct geometry, and analyzing the loads properly, engineers can ensure that antennas stay stable throughout the flight. This combination of design and material choice allows for high performance and reliable communication systems in modern aircraft. Thank you. My presentation here is